Hi, Math 20s. This is the next lesson, I don't know, maybe lesson 8 of angles and triangles, the cosine law. So, um, the last kind of two lessons were related to the sine law. So first kind of our um, derivation of it so that we could use it. And now we're going to use the cosine law. And so it says the sine law cannot always help you to determine an unknown angle or an unknown side length. So let's give us a triangle here. So triangle QRS. So, why is it not letting me write? There we go. There we go. So QRS. And so we're given the measure at angle Q is 66, and that's the only angle that we have. And then we have side length S and side length R. So if we were to set up our sine law, so we know we have side length R is 3.1. We know we have side length S is 3.2, and we know we have angle Q as 66 degrees, but we actually don't have any other pieces of information. So no matter what we set up, so if we pick any two of this, well, we have two unknowns. Or if we pick these two, well, we have two unknowns. So we can't actually rearrange to solve when we don't have the side that's opposite the angle that we know. So when we don't have side length Q, we can't actually do anything. And this is not a right angle triangle, so we can't use our Pythagorean theorem, oops, equals c squared. Sorry, that's a hot mess. Let me see if I can erase. So I can't use my Pythagorean theorem because again, this is not a right angle triangle, right? I don't have a 90-degree angle anywhere that I'm given at least. So the sine law actually can't help us out here. So we can't use the sine law because we have an unknown in each of those ratios. So we have an unknown in, sorry, ooh, sometimes it like lets me do this. Yeah, there we go. So in our ratio for R, we have an unknown right there. In our ratio for S, we have an unknown right there. And in our ratio for Q, we have an unknown right there. So that's why we can't use the sine law in this case. So the next part says we need to use the cosine law to solve this. So there's two different forms for the cosine law. Both are on the formula sheet. So form one, so we use form one when we're looking for an unknown side. And what we need in order to do this is we need to know two sides and the angle in between, which is what our situation is here, right? We have two sides and the angle that's in between them. So we would be able to use that form to find the third unknown side. The other form that we could use is if we're looking for an unknown angle. And so in order to do that, we need to know all three side lengths for the triangle. So just looking, because I don't think I have this solved anywhere, so looking at the question that we have above, I have a little bit of room here. I'm just going to try to solve using that form one. So like we said, we have two sides and the angle that's in between it. So what might be the best scenario, just because like we have it with A, B, and C, and I don't want you to, oh, of course, I thought I was erasing there. Boop, boop. I don't want you to get confused with the Q, R, and S. We need to call A our unknown. So I'm going to just rename my triangle just to make life easy. So A is my unknown, so that would need to be A over here. And then it doesn't matter which is B or C. So I'm going to do B and C. This would be lowercase b, this would be lowercase c. But just so that I'm sticking with the same way, you could rewrite your formula in terms of your unknown, but I'm just going to rename my triangle. So again, it's saying a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of a. So I'm just going to slot in those pieces of information that we have above. I have to keep scrolling up because I don't, oh, I guess I have my sheet right here. So b squared is 3.2 squared. I just realized that I actually don't have a calculator with me, so I'm just going to show you how we would do this. So c squared, so side length c is 3.1. And then minus 2 times b times c B was 3.1 and C was 3.2. Sorry, I'm running out of room, so then you'd have to multiply it by the cosine of 66. And so looking at the triangle, so you'll want to punch that into your calculator because you probably have one somewhere. Actually, I might have one in my bag here. I do. I am amazing. So 3.2 squared. You might need an extra set of brackets around that last portion just to make sure that you're subtracting everything. Subtract 2 times 3.1 times 3.2 times the cosine of 66. Close all the brackets that I had. Uh-oh. Oh, yes. I was like, I did something wrong, but I did not. So I've solved for, so a squared is equal to all of those things multiplied. So a squared, what I get out of my calculator, is 11.78. But what we're looking for is a, not a squared. So now I need to square root that answer, and I get 3.43 meters, centimeters, meters. And then just looking back at that original question, does that answer make sense? 3.4? Yeah, that probably makes sense, right? 3.2, 3.1. I was distressed when my answer was 11.78 because I was like, well, that doesn't really make sense with the rest of the triangle, but that's because I needed to, in the end, square root my final answer. Okay, so that's how we use it. I think that's what the next question is kind of like as well. So again, if you're looking for an unknown side, it's solving for an unknown side. If you're looking for an unknown angle, it's solving that way. So determine the indicated side. So I see right away, indicated side, going to use form 1 of the cosine law. Because again, it's asking us to look for a side length. So this triangle, thankfully, is labeled ABC the way we would want it. So side length A is my unknown side here. This is what I'm looking for. So if I needed to relabel my triangle, I could do that, but thankfully this one is actually good. So A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. So just substituting in the values that we have. So again, this is side length B because it's opposite angle B. This is side length C because it's opposite angle C. So 32 squared plus 40 squared minus 2 times 32 times 40 times the cosine of 58. So when I put it into my calculator, I've probably got an extra set of brackets around here just in case, just to make sure that I'm subtracting all of this product. So all of these things multiplied. It should do it properly, but I'd rather throw in an extra set of brackets and not have it do something funky. So I always put an extra set of brackets around that. And so now punching it into the calculator, you can break it into steps as well if you want. So 32 squared is 1024. 40 squared is going to be 1600. And then if I multiplied out all of this jazz, I think I get 1356.59 something. So you can put it all in as one thing, that's totally fine, or you can break it into parts if you want to just make sure that you don't mess up anything. So I get an answer here of 1267.41 something. But again, we're looking to solve for side length A. This has given us A squared, so we need to square root both sides in order to solve for A. So if I take the square root of 1267.41, I get 35.6 meters. And again, thinking about looking at our triangle, yeah, that makes sense, right? 35.6 makes sense. 1267, hopefully you wouldn't, get stuck at that answer and be like, yeah, that looks good, because that doesn't make any sense with that triangle. So that's the cosine law, that's the form one. Obviously, I'm going to make you do the second form one time. Um, so looking for an indicated angle or an unknown angle. So this is form two. Oops. And so just flipping over back to the other side, form two is the cosine of angle A is equal to b squared plus c squared minus a squared. So you need to know all three other side lengths. You need to know a, b, and c, divided by 2 times b times c. So the first thing I need to do is label my triangle because there are no labels on this one. So I'm going to make my unknown angle A here. So I'm going to make that angle A. So this will be side length A. And then again, it doesn't matter which is B or C. So I'll make that B, and that C, that C. Doesn't matter which is which. It won't make any difference because again, you're adding here and multiplying there. Not a problem. So the cosine of angle A is equal to b squared. So b is 6.3 plus c squared. C is 7.1 minus a squared. A is 5.4 divided by 2 times b times c. So again, you're welcome to put it all in your calculator. You'll definitely need a set of brackets right here, or you can break it into the smaller parts, right? You can do all of the individual steps. So 6.3 squared is 39.69. 7.1 squared, 50.41. 5.4 squared is 29.16. And then multiplying that whole bottom part, so 2 times 6.3 times 7.1 is 89.46. Hopefully you're punching this into your calculator, either trying to punch it all in as one step from right here or doing the individual steps. Either is going to get you there, but if you find that sometimes you make a mistake punching things into your calculator, break it into the little steps. And so then I probably would put it all in my calculator at that point, and I would get 0.681198, yada, 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 yada. And so hopefully at this point you wouldn't be like, all right, I guess angle A is 0.68 degrees, or hopefully you wouldn't be like, I guess I'll just make it 68 degrees because that has that number. What we've solved for is the cosine of angle A. So we've looked at that ratio. So what we need to do from this step is take your inverse cos here to solve for A. And that gets us A equals 47.1 degrees. That makes more sense, right? 47.1 degrees. Again, if you're not getting the same number, like if you punch this in your calculator and you didn't get the same number as me here, if you didn't keep enough decimal places, that's going to give you an answer that's a little bit off. Like if you instead put 0.7, just to give you guys information, if you put 0.7 there, you actually get 45.6 degrees. So keep more decimal places. It's going to give you a better answer. Or if you're getting some other sort of funky answer, so I'm just playing with my calculator to see what your funky answer would be. Cos negative 1.681198. If you got like 0.82 from there, it's that you're in the wrong mode. So you need to switch your calculator into degree mode. Hopefully you've done that by now and you haven't just been trucking along in radian mode, but make sure your calculator's in degree mode. All right. One more. This question kind of annoys me sometimes. It says the diagram at the right shows the plan for a roof with support beam DE parallel to AB, the local building code requires that the angle formed at the peak of a roof to fall within the range of 70 to 80 degrees so that the snow and ice will not build up. Will this plan pass the local building code? This question has just some things that you don't need at all, and it's kind of irritating in that regard. So, like, it's giving us this support beam, DE, parallel to AB, but that doesn't matter. I don't know why they needed to give you that piece of information, because what you're looking at, again, it's like looking at the roof. So this is the roof of what I find to be a weird shaped house. So it doesn't matter where that support beam is, right? It's asking about the angle that it makes, that this angle needs to be within 70 or 80 degrees. So 70 to 80 degrees? Question mark? That's what it's asking. The other stupid thing is, I guess we use feet and inches. I know we do. Like if I ask you your height, you're never going to tell me centimeters unless you're looking at your driver's license or your learner's license and you have that piece of information. People always give feet and inches. But then when we're asked to do some calculation stuff, sometimes people don't really know what's going on. So this one is 20 feet across here. This one is 10 feet. This one is saying 19 feet 6 inches. What that actually is 19.5 feet. So there are 12 inches in a foot. So 6 out of 12 is a half, or 19.5. So that's another reason that this question kind of irks me. I'll write a little star. Change the Q. But I guess the important part is extracting the right pieces of information from it. Okay. So looking at that. So what we have 3 side lengths. What have I written? Oh, I need an H there. Need an angle. So we're going to use that form number 2 because that's looking for an unknown angle. Just to continue piling on the kind of annoying things, is we're looking for this angle up here, right? So the way I have that labeled is I'm looking for angle B. So again, you can rewrite your formula in regards to that, or you can just relabel your triangle, that A and B are those ones instead, and that works out A-okay. So based on my new labeling, since I crossed those out, this is side length A, this is side length C, and this is side length B. So now using that form 2, the cosine of angle A is equal to B squared plus C squared minus A squared divided by 2BC. So now looking at how we labeled the triangle, so side length B again is that 19.5 feet, not 19.6. 19.5 squared. Side length B is 10. And side length A is 20. Oops. I guess it doesn't matter what order I write it in. All right, so again, if you want to put it all in your calculator at once, an extra set of brackets out there won't hurt you. Or if you want to break it down into kind of the individual steps, so 19.5 squared. No, it's not. I know that one. I know that one. Why did I write plus? 390. I don't know why there's brackets there. Okay, so I've broken it into the step. Again, you can kind of skip over this step if you need to, but if you find you're making the mistakes, break it into those individual steps. So the cosine of angle A as my relabeled triangle is equal to 0.20576. Again, try to keep some decimal places. I usually keep at least 4. Don't round to your nearest tenth or something until you're at the end. Well, so we get angle A equal to 78.125 degrees. And so now just looking back up the question, it says, will this plan pass the local building code? And again, the local building code requires the angle formed at the peak of the roof to fall within the range of 70 to 80 degrees so that snow and ice will not build up, but also not so steep that you'll fall off and die. That's pretty steep. I probably would fall off. So yes, it will pass the building code. Um, yes, so that's it for the questions for today, or the lesson for today is what we'll say. So in the textbook, you're looking at page 150. That's supposed to be a G. Page 150, so 1 through 5, 6AB, 7AB, 9 and 13. Again, do these first. Practice those skills because you can, again, usually there's answers for them in the back. And then after that, you have an assignment called Applying the Sine and Cosine Laws. That you guys can start working on. Our next lesson will be kind of more word problems again. I know that last one was a word problem, but we'll look over 2 more word problems that you can see. You'll have a little bit of time still to work on that assignment, so don't rush to get it done right away. And then we'll be looking at a quiz again sometime soon, and then your angles and triangles unit test, but not super fast. I'll give you guys the dates on those ASAP. So have a good one. We'll talk to you later. If I can click on this. Bye, guys.